we're going to move on to AS level of chemistry. It's not, well, it is actually very, very different from the IGCSE stuff because it's a lot in greater detail. So to start off, this is an AS level chemistry. So they give you this table as stated in the syllabus. Of course, they expect you to understand the terminology, okay? There is something stated in the syllabus that they say alkane is not a functional group. So they specify that alkane is not a functional group in the syllabus. If I go further down, formula, functional groups, and the naming. So define the term hydrocarbon. I think you should be all right with that. Understand that alkanes are hydrocarbons with no functional group. So, you know, if you have a molecule and then they ask you what are the functional group present, you shouldn't write down alkane because, you know, alkane is not a functional group. Okay, so that is actually quite a new thing set in the syllabus. It used to be they don't state it, and a lot of students thought that they could just write down alkane. Even I thought so as well, but apparently alkane is not a functional group. So, you know, so we now know that, you know, if they ask you what are the functional group present, you don't put down alkanes. Okay. Now, understand that these compounds contain a functional group which detect their physical and chemical properties. So each of those one you need to know general molecular formula, structural formula, display formula, and skeletal formula. My favorite is my skeletal formula because you are expected to be able to draw skeletal formula. However, if the question asks you display, then we just simply show every single bond. So the display show all covalent bonds. And then structural formula basically is must see the structure. So it's slightly simplified, but you must see the structure from structural formula for obvious reasons. And as stated in the syllabus, aliphatic means straight chain. So that means, you know, not aromatic. Actually, aliphatic means not aromatic. Whereas aromatic means something to do with benzene ring. Aromatic is A2 chemistry. Arenes is A2 chemistry, has to do with benzene ring. So what else do they say? Up to 6 carbon atoms. So they can ask you up to 6 carbon atoms. So we will practice later on with up to 6 carbon atom. Yeah, 6 plus 6 for ester because 6 carbon for the alcohol, and then 6 carbon for the carboxylic acid. So potentially 12 carbon altogether. But they specify they can ask you up to 6 carbon for the alcohol and 6 carbon for the carboxylic acid. 6 plus 6 straight chain only, ester and nitrile. So that means they cannot ask you branch chain, they can only ask you straight chain because whatever is stated in the syllabus is the syllabus, you see. Okay, these are very specific stuff. So these are very specific stuff in the 2022 syllabus onwards. So it might be how they plan their question are going to be like for the next 3 years in this series, okay, which you'll be teaching.
Yeah.
Now, deduce the molecular empirical formula. So obviously, count all the atoms. Count all the atoms. So the actual number of atoms in one single molecule. So if they show you one molecule, you just need to count everything and then simplify them so that you get the simplest whole number ratio definition of empirical formula. So I'm just going to quickly go through this list here. So you will know that alkane is not a functional group now. So another thing that I used to make a mistake on quite a lot, you see the name of functional group, you see carbonyl is a functional group. Carbonyl is a functional group. We need to be very careful. State the functional group. Ketone is not a functional group. I think I might have made that previous mistake because previously they did not specify this thing very specifically. So these days, if they say state the functional group, if you write down aldehyde, that is not correct. Aldehyde is not a functional group. Okay, so we just need to, you know, keep track of what is in the syllabus nowadays. So aldehyde and ketones are simply the class of compounds. The topic is called aldehydes and ketones. They come under carbonyl compounds because carbonyl is the functional group. All right, like halogenal alkane is the class of compounds, but halogen is the name of the functional group. Hydroxy and non-alcohol. Hydroxy is functional group. Name the functional group. Hydroxy is the functional group, not the alcohol. So be very careful, right? So what I thought all this while as functional group, that has been class of compound. So when you watch through some of my tutorial videos, even the free ones, just keep an eye out for that. It used to be not properly classified. Nowadays, they have properly classified these. And I realized that these are adaptations from the IB syllabus because I tutor for IB as well. So back then, A-level wasn't this specific, but IB has always been very, very specific. The other thing is carboxylic acid. This is carboxyl, not carbonyl. Carbonyl is to do with ketones and aldehydes. The carboxylic acid functional group is carboxyl, and the class of compound is carboxylic acid. I think the rest is pretty much the same, so we don't need to go too much into detail there. You should be okay with alkane, alkenes, halogenal alkane. So when you have X is a halogen, so it could be chlorine, bromine, iodine, and then alcohol. This one is display. Display means show all the bonds. And the most common mistake that students make is they show this as OH and they will lose the final mark because they did not show the covalent bond. Show all covalent bonds. Okay. Ketone and aldehyde. Aldehyde has a hydrogen on one side and a carbon on the other side, either side of the carbonyl. So it's CHO. That's the way you write down the structural formula, RCHO. The structural formula here will be RC bracket or R. Sometimes people write it as RC double bond or R. Both of them are correct as the structural formula. Okay. What else can I say? Carboxylic acid, again, look out for the OH. And ester, ester can be written as COO like that, or you could also be writing it as C double bond OO. So this is also correct. This is also correct. It's just that they are both the same, whether you read from left to right or right to left, they are the same thing. So it really depends on which one you want to read it in. This is amines. In an amine, you must have lone pair on the nitrogen. That's what makes amines an amine. Okay. Now nitrile, the nitrile thing is very special. It's the carbon nitrogen triple bond there, because when we think about hybridization, this is the one thing that I like to ask you, right? Hybridization. We talked about hybridization before. It could be sp3, sp2, or sp. We count the sigma bond. So there is one sigma and one sigma there because there's 2 pi and 1 sigma. So 1 sigma, 2 sigma there total. So there's 2 bond pairs and 0 lone pair since the carbon form 1, 2, 3, and 4. So your shape of molecule comes from 2 bond pair repelling equally. That is your linear 180 degrees, should be no problem. However, your hybridization depends on your total number of electron pair, which is 2, and that must involve the carbon S. There's 1 of it. It must be 1 plus 1 give you 2. So it's sp hybridization, linear geometry, 180 degree there. Take note that when you draw the skeletal formula, this is the one thing that people always draw incorrectly. They draw like this. This is wrong because it is supposed to be linear. It's supposed to be linear, sp hybridized center, because they thought they have to invert, they have to like make it at an angle. They can't. This is a linear geometry. Therefore, when you count it, it's 1, 2, and 3. When you name nitrile, 1 start from the carbon of the nitrile. So this is 1 carbon, 2 carbon, and 3 carbon. Propane nitrile. Happy with the name? I mean, you can get another one, which is ethane nitrile. So ethane nitrile is basically CH3, CN, CH3CN. So it's just 2 carbon, including the carbon of the nitrile. Butane nitrile, you can get butane nitrile. It would be like that, 1, 2, 3, 4. That is going to be butane, so 4 carbons, and then name a nitrile. Happy with that? Okay.
Shishen,
as for
how
the,
you draw butane nitride, is that correct? Is it the correct way of drawing butane nitride? Or should it have been shown in a linear form?
Isn't it butane nitrile? Because I mean 1, 2, 3, 4. So there are 4 carbons. So it's butane. Nitrile is C triple bond N.
No, so should it not be is this linear form only? How you had
this
spoken
this
that,
is supposed to be linear. Okay. So I think what you're saying is it should be like this. You're saying it should be like this. Am I correct? Is that what you're saying?
Yes.
Okay, if you look at the junction here, do you see the junction there? Do you see there's like a breaking as well because they show the triple bonds? It looks very fine on paper, but you see there's a junction there. So that is what I'm doing there. So I am trying to draw the junctions like this to show that there's a breaking point there, so that I could very clearly see that this is a carbon. Because sometimes when I just draw straight like that, I might miscount it. Okay, I mean it's a usual habit. You can draw them straight like that where it's shorter or longer. It doesn't matter. It's just that it's easier to take note of these things and not make any mistake in counting. Okay.
All right.
Now, naming
Okay.
propylamines, of course, you can have ethylamine. So this will be 1 and 2. So 2 carbon amines. Of course, you can have butylamine, pentylamine, up to 6 carbon, right? Up to 6 carbon. Remember what they say? Up to 6 carbons, up to 6
Right.
carbon. So you can have hexane nitrile, pentane nitrile, butane nitrile, etc., etc. So practice the name up to 6 carbon. Yeah. This is up to 6 plus 6. That's what they say. Up to 6 plus 6. 6 carbon, there will be hexal, and then 6 carbon, there will be hexanoate, up to 6 plus 6, something like that. Okay. So give or take, I mean, you should know how to draw the skeletal formula. Do you have a problem with skeletal formula?
No.
You're okay with it. Okay. All right. Cool. I think the next bit really is, so students often struggle with skeletal formula, right? So the first thing they do is they will ask the students to draw randomly. You will draw a random structure, and then you ask them how many hydrogen is there. Okay. So how many hydrogen is here?
3.
3. And then the next one, how many hydrogen is there?
2.
And here?
0.
And here?
3.
Okay, so you get the idea really is keep on reciting the mantra carbon form 4 bonds. Okay, I think I always specify this in my tutorial when I come to organic chemistry, carbon form 4 bonds. So think about how many is shown, and then think about how many hydrogen is not shown there. Okay, so I believe you when you say, okay, all right. So, but the main problem, the main concern is always the student. They're seeing it for the first time, and they will not be okay with it. And they will be like, it's too simple that they don't want to use it. But the key is they must learn to use it no matter what, because when they come to A2, then if they don't want to use it, if they haven't gotten used to it, then when get thrown, a whole big molecule with skeletal formula in A2, they're going to struggle with it a lot.
Right.
Okay?
Right.
All right. Now, should we move on? Now, interpret and use the following.
Is it compulsory? Excuse me.
Sorry?
Is it compulsory in AS level to draw skeletal formula, or is it optional?
It's not compulsory, it's optional, but you must have seen question. If the question specified, like display or structural or skeletal, then they have no choice. Then they have to, if the question specified. Okay, but I've seen these days, I think from 2016 onwards, you must have seen this type of question as well. If you do enough past the papers, you will see that the question said draw the structure. So you see, they say draw the structure. So this is free option, free choice. You can draw either. Either. Now, if a question asks you to draw specifically display or structural, but I still prefer to go with skeletal because it is faster. It's faster. So if a student can do skeletal first, and then from the skeletal, like if I can get this, and then I can get this, I can see that it's reductions. So what happened then is I just draw that, and then I can convert that to my structural formula very easily. I mean, they want this, but it doesn't stop me from doing this first and then convert it to this. And this is faster than having to, see this and not counting whether it's correct or not. You got to draw and see it, then you'll be able to write it out. That's my point. It is never compulsory unless the question specified. Okay? So I think that's something that the student needs to appreciate really. It's not compulsory, but in the real exam, if they do multiple choice question, if they have 1 minute and they try to do display and they still couldn't get it in 1 minute, then what are they going to do? Fight or run, something like that. Okay.